Morning, everyone. How y'all doing?
It's Friday.
It is Friday. Yay! Let's see, this particular Friday. This particular Friday is the last Friday of September. And once again, to keep it in your minds, next week, October 2nd through 6th, is the week of our first test. We have officially ended Chapter 5, and the last new material before the test, and so next week is the test. I've said that already. Today, I plan on going over everything that we talked about the past month and a half, make sure everyone knows what will be on the test. Lecture next week will be more review, so that everyone who takes the test any given day will be ready before that afternoon. And test will be during lab time next week. So next week, instead of lab, you report to this room during lab, and you'll take the test then, so you don't have to rush through it during lecture. Which again means lecture next week will be more test review. So, whatever day you have the test, come that morning for review, ask any questions you have, and then come back that afternoon for said test. That does mean that you can take the test any day that there is lab. You don't have to come to your normal lab day to take it. You can attend either Monday, Tuesday, Wednesday, or Friday. There is no Thursday slot. Thursday is a myth. Now, what I recommend doing to help you study for the test on your own time is homework and quiz, chapters 1 through 5, and also the practice test on WebAssign, found here in the Test 1 tab, Test 1 practice problems. And I have already uploaded an answer key showing both the answers and my work in red. What happened there? Showing both my work and my answers. Again, the practice test is both longer and more difficult than the test itself. That is on purpose. Yes?
Do we have to let you know what period we're coming to, or do we just show up?
You do not have to let me know. You do just have to show up. If you come Monday, Tuesday, Dr. Edwards will be here proctoring, and then Wednesday, Friday, it'll be me. Like it works with normal lab. But there's more seats in here, so it doesn't really matter. I don't have to keep count of how many people are there, so you can just show up.
Okay.
You can choose to take it Monday if you want it over with. You can choose to take it Friday if you just want more time to study. How you guys feel?
I'm not confident.
Oh no.
Yeah, same. I'm so scared.
Oh.
Well,
Thank you for telling me that.
They're scared to test out. They only get right now.
It is your first physics test, and you know that is inherently a nervous thing. Couple things I'll go ahead and mention in an attempt to make things less nerve-wracking. There is bonus points on the test. There is not a bonus question. There is just more points than you need to get a 100. That way, like there's 9 questions. If you add up the points of every question, they add up to 105 out of 100. And I grade it out of 100. This way there's no one bonus question, and then if there's only one bonus question and you don't know it, then you just lose out. So I prefer this method to make sure everyone can benefit from the system. Question?
I'm gonna miss this. You said there's 9 questions total?
Yes.
Okay.
7 of them are mostly math. If 7 are mostly math, 2 of them are concept, word, short answer. I will also point out that one of those word questions is identifying the laws of motion. I say that one a lot. Make sure you know the laws of motion. Yes?
You can use our formula sheet, right?
You can. And you can write all over your formula sheet. The few rules about what you can and can't write on it are: one, you can't write the answers, which you shouldn't have in the first place. Two, please do not write out the laws of motion. Technically, one of them is already on there though, since the second law of motion is just a formula. It lives, where is that? Yeah, right there. Oh, that already gave one of the answers away, didn't it?
Yay.
Make that the question.
Well, that is part of the question. I list out 5 statements, and you have to pick which one are the laws of motion and then number them accordingly. So as long as you bring your formula sheet, that's one of the answers right there. Additionally, because everyone's relationship with math is different, most of the questions are written as math word problems, but I again give partial points for everything. So if you are just stumped on math, first of all, I want you to ask either me or Dr. Edwards to make sure, like, you're allowed to ask questions. I want you to at least make sure, I want to at least make sure that you understand what is being asked of you. I want you to ask questions if you are honestly stumped. And then if you still are drawing a blank on how to do the math, you get points for everything you write, including just a paragraph about what you think's going on. Like if I ask you, if I give you a ramp and I ask you, how do you find normal force on an incline, and you are just drawing a blank, start writing any information you know about the relationship between normal force and everything else going on here, because that will earn you more points than leaving it blank. The only way to get a 0 on my test is to leave it completely blank. As long as you try everything and give an honest answer and write some scientific answer for everything, like the minimum you should expect is a 50, as long as you try and don't leave it blank. Yes?
Do we need to write conversion factors on our
No.
equation?
Any conversions that you need, I will provide. The only exception to that is metric prefixes. But you can write, you know, King Henry died by drinking chocolate milk on your formula sheet. But anything else, like feet to meters, I will provide. Because half of those I don't have memorized, so I will provide those. For a similar example, on the practice test, I've got 2 conversion practice questions here. Conversion factors are provided, because I can never remember how many meters are in a mile. Yes?
On our equation sheet, are we allowed to like put like our own little like example like questions on the back, or like from the homework, like just to help us remember like the steps?
I usually don't let like full worked questions be on there, but no. Sorry, no, no one's asked me that straight out. I'm trying to on the fly verbalize my opinions on the matter.
Or like, for example, like with the attention questions that we did in class, like I just put, okay, attention question, and then put like step 1, use this equation, step 2, do this, step 3.
That feels okay. Yes.
Okay.
Like if you are describing the process in words rather than have a whole bunch of algebra written down, like pre-worked question. If you are describing your method, that sounds fine.
Okay.
No one's asked me that flat out before. Also, make sure you bring a calculator that is not your cell phone. How you guys feeling? Okay. Again, oh, sorry.
Do you know like, my bad. Do you know when we'll get like our scores back, or?
Yes, my plan is for them to be graded and back in your hands by the 11th or the 13th. 13th is the absolute latest because midterms go out that day. So I will have them graded before Friday morning of the 13th because I need to have midterm grades submitted by 9 a.m. that morning. So the latest I will finish them is Thursday night.
So, is that also when you're gonna tell us when if we're passing or failing?
Yes.
Okay.
You will have the test in your hands by Friday morning, and once I give it to you, it's yours. That's your work. You keep it. We'll spend Friday looking over my answer key, making sure everyone understands what happened on the test, and you'll have then your test score. The midterm score that you will get that morning is your current class average, and that's really just C or above passing midterm. D or below, you get a more specific mark. That does, now that is your class average, not just the test score. And when those go out, if you have any questions, I don't like the midterm system because like, it's not specific enough. Like you get just S for C or higher, really.
Oh, so you don't know like A or B?
Oh no, I know,
Oh.
but I don't get to enter that. The machine asks, is their grade satisfactory or not? So I would love to give you a more specific letter grade, but the system doesn't do that. So when midterms go out, I anticipate a flood of emails of students asking, what's my actual letter grade? And I will provide that information once I've calculated it. Like I will tell you what the score is. You'll have to ask me specifically since the machine will only tell you S if you have a C or above. Yes.
Could you post it on Brightspace?
Like your scores?
Yeah, like make it like a midterm exam and then put the grade in for it.
I know a lot.
Mhm.
I have not actually used Brightspace to show grades before.
It does have a grade.
You know what?
It does.
You know what?
It's alright.
It's a race.
That will be something for me to play with.
Okay.
We'll try to get that working. Any other remarks about the upcoming test for right now? Okay. Well, the overarching plan for lectures for the next week is going to be focused on test review. That is to say, most of those days, if you guys have had any questions working on homework or the practice test or anything about the test itself, lecture is going to be the time to ask those things. Because odds are, if you're confused about something, someone else in the room probably is too. And I want to review the things that you're having trouble with you, help you with the homework that you're working on, and also make sure that the stuff on the practice test makes sense. So, general policy for the next week is the floor is open for any and all of those inquiries. Now for today specifically, I did prep an extra example question I'd like to do with you guys to summarize the last two Chapter 5 concepts we'll look at together. And then I'm also going to look over very briefly the concept list for the test, make sure you've heard out loud everything that's going to be on there. And then I'll open up the floor to any other specific questions you guys have. Any objections to that plan for right now? All right. So the last two things we talked about on Wednesday were elastic potential energy and power. And I figured out one example that contains both of those things. We are going to examine the power output of a robot. And this robot is stated to have a power output of 1,500 watts. And what this robot is going to do is they are going to physically push against this wall-mounted spring in order to compress it. And we are going to see how much work they do in this task. As the robot begins compressing the spring, it takes them 10 seconds to compress the spring a distance of 75 centimeters. And with all that information given, my first question is, how much work does the robot do in that amount of time?
The force times the distance.
That is true. Work equals force times displacement. Do we know the force the robot is exerting?
No.
Not yet, anyway, we don't. So, what other options can we explore? What other formulas involve the concept of work? Power. Definition of power is work over time. We know the robot's power output and the time it is acting, and we want to know how much work it performed. So, perfect formula for this scenario. Power output of 1,500 watts equals our unknown work over 10 seconds. Bless you. So, the robot should do about 15,000 joules worth of work in this exercise. That'd be 1,500 times 10 when you move time over. Any questions on finding that answer? All right. Now my next question is, that is the amount of work the robot does, that is the energy the robot uses up. It now has 1,500 joules, 15,000 joules less than it had a moment ago. How much EPE should the spring gain in this scenario? Assuming that you don't lose energy to pesky things like friction, if the robot is using up this much energy, all of it has to go somewhere. And since the robot is acting upon the spring, again, ideally, all of it should end up inside of the spring. So, conservation of energy. Robot had this energy, used it up to do work, it has to go somewhere, and it's going to become EPE in the spring. How's that sound? Okay. Last question then. If this is the EPE that the spring is going to absorb, what would its spring constant need to be to absorb that much energy while only compressing by 75 centimeters? What formula summarizes the relationship between EPE and spring constant? Yes.
Would it not be like the force of spring is equal to K times displacement?
We could use this. There's only two formulas with spring constant in it, so this is absolutely one option we could take. We want K, we know how much the spring compresses by, so we would need to know what force is being acted upon the spring in this moment. So if we had that force, we could find K using this method. So that would work if we had that information. We could figure this out. There are ways to find the force needed to do this.
Is it 20,000
For the spring constant or for the force?
for force?
Let's find out. Because we found the work and we know the displacement, so we can't actually figure out what the force is now. So this will work, just takes a few steps. Yeah, 20,000. So the force requirement would be 20,000 newtons. It's a very tough robot. So 20,000 equals K times 0.75. That'd be,
Is that meters for the 0.7?
yes, the 0.75 is meters. We were told 75 centimeters. So 20,000 divided by 0.75 N. That would be,
It's like 26,666.
thank you.
Should the K be negative?
Yeah, that's what I was wondering.
Yeah, so, technically no. And if, the reason that this negative is in this formula is because the force the spring exerts is always opposite the spring's displacement. The spring is displacing to the right, so the spring is gonna act to the left. Over here, we calculated the force the robot would exert to the right. So technically, if this is supposed to be the force the spring exerts, that would point negative to the left, and that would cancel out the negative in the formula. So spring constant should end up being a positive answer, and this is how the negative in the formula goes away. So negatives cancel. 20,000 divided by 0.75 should give us 26,006 repeating. What are the units for spring constant?
Newton divided by meters, so it's like.
Yep, newtons over meters, because it's the force required to change something's length by 1 meter. And that is a very big spring constant, so this is a very powerful spring. Yes?
Can you show it the way using the EP formula with the like 1/2 K? Can you use that?
I can. Although,
So I end up getting double, like the spring constant is double like that.
yes. What I think that means is, one, I wrote an imperfect question, and two, I think that my intended route was with the EPE calculation, and I do think that actually this method might be flawed slightly. The reason being that the robot wouldn't actually be exerting this much force the entire time, because the spring increases the amount of force it fights back with as it is compressed. So it's very easy to compress at first, but it gets harder the more it's compressed. So if you did this on the test, like, I'm not gonna ask exactly this question. This is a weird example that I came up with this morning. Realistically, this method is slightly flawed for that reason, but I still give you credit for it because you do get an answer in following the formulas. But realistically, it's flawed because this force wouldn't be constant. My intended path was noting that the spring would gain $15,000 joules of EPE, and you could use that to find K. And using that method, I too just calculated,
You get exactly double.
yeah, exactly double. So that would be my preferred tactic, because again, using the other method, that force isn't actually constant the entire time. Yes?
Are we gonna have like this on the test, like that either one can give you like different?
Well,
It's like then how do we know like which one is the right one?
right. Let me check how I wrote the test question real quick. Okay, the way that I wrote any relevant test questions using this concept, the other way shouldn't come up. Like, there's nothing you would need to do the method that didn't quite work. But I will double check all my wording to make sure that it's absolutely clear. So, officially, this is the tactic I would endorse because the force is not technically constant the entire time doing it the other way. Again, I will make sure my wording is completely ironclad to make sure that it's absolutely clear on the test.
So there's a test question that's like this.
Well, there's a test question that involves springs. That's about all I can say, being very coy. Yes?
What type of question would we use that equation for that for?
Hmm. Okay, so I'm gonna try to not be coy because I know you guys are anxious and need concrete answers to calm that. This is kind of spoilery, but I have written the test such that this formula doesn't actually come up.
Cool.
That just happened to be how the questions fell. And so to try to alleviate your anxiety, you technically don't need this formula for the test. So if you put a little X next to it to tell yourself any spring questions, you should use the other one. Is that a more concrete thing to tell you?
Yes, thank you.
You're welcome. So that means there's only one equation with K in it that you would need to actually use on the test. So if K comes up, the brain should go here automatically. Questions? Speaking of concrete non-vagaries, let's end today by looking over this list of things that will be on the test, and I will try to give you in as most absolute terms as I can what things you need to be able to do for it. The tab itself, when you just click on what says test 1 right here, this is a list of everything we've covered that will be represented on the test somehow. This is a list of like 20 things, but that doesn't mean there's 20 questions. One question might reference 2 or 3 of these concepts, since they're all interconnected. But if you look over this list and you feel comfortable with every individual thing written on it, you will be fine. So from the beginning of the course till now, started with unit conversions, so do make sure you can do those. Practice for unit conversions includes number 12 on the practice test. Then we started learning about vectors. The first 3 vectors we did were displacement, velocity, and acceleration. And we used those first 4 formulas we learned about to show the relationship between all of them. So to summarize all 3 of these things, know that if something's a vector, we care about its direction and its axis. That includes positive and negative within that axis. So always be very careful noting those things in your work. As for displacement, velocity, acceleration, and these formulas, that is again referring to these 4 right here. Make sure you know what all 4 of these things do. We use these formulas to describe both 1 and 2-dimensional motion. 1D motion is just back and forth in a straight line. 2D motion is back and forth in 2 different axes at once. The biggest examples, plural, of 2D motion that we have looked at include projectile motion, which again is an object falling as it moves through the air. If you're falling, what is your acceleration? Yep, accelerating because of gravity, very good, and the number for that is negative 9.8 meters per second squared. That number is not printed on your formula sheet, so if you haven't memorized it, you should probably scrawl it on there somewhere. What axis is this in? What axis is it not in? Very good, so if something is falling, this is automatically its y acceleration, and its x acceleration is automatically 0. Yes?
Okay, this might be a dumb question, but for the gravity, like in some equations, we put it as like positive, and other ones we put it as like negative.
Right.
So like when is the right way to use the negative or positive?
Now, to try to mitigate the phenomenon you have just asked about, I try to be consistent in saying that G is always negative 9.8, and there are a handful of very specific formulas like this one, GPE, MGH, where the G term should have absolute value brackets around it. So technically, my official answer is G is always negative, and there is at least one formula where the brackets remove the negative sign that is always there. Does that answer the question?
Yes, thank you.
Okay, you're welcome. Now, a given question may end up, like, you may have to plug in negative 9.8, and it may end up, like, needing to be moved to the other side and end up a positive number, but G is itself still negative. And additionally, if you haven't already done so, put absolute value brackets on the GPE formula on your equation sheet. So 2D motion, projectile motion was the first example we covered, but vector addition also constitutes 2D motion a lot of the time. And so to make sure you are prepared for 2D vector addition, make sure to practice your trig. You can't have SOHCAHTOA written on your formula sheet. And make sure that your non-cell phone calculator has sine, cosine, and tangent buttons. And also inverse sine, cosine, and tangent buttons. Questions about anything from chapters 1 through 3, I think that was. Bless you. All right. Next things we talked about, acceleration of gravity versus the force of gravity. Again, that's the acceleration, and we use it to find the force. That number is not the force of gravity. We use it to find the force of gravity. What is the full formula for calculating the force of gravity?
FG equals mass times gravity.
Very good. So if I ask you, how do you calculate weight? The answer should be m times g. If I ask you how to find weight and you write either m by itself or g by itself, I will be sad. Gravity is a force, ergo we talked about forces and Newton's laws of motion. Again, you have to be able to identify them. You don't have to necessarily write them verbatim from heart, but you have to be able to identify them and then number them accordingly. The numbering goes, first law is inertia, second law is F equals ma, third law is action-reaction. As long as you can remember that, you should be able to identify the statements. Things we covered in chapter 4 related to forces include the concept of net force, which is what causes acceleration. Net force is again defined as every force present on something added together. If net force is 0, the object doesn't accelerate. If net force is not 0, it will accelerate. And usually you have to examine net force in both the x and y axes separately. And also, you will be required to draw at least one free body diagram, so do remember that that term refers to draw a picture with arrows for every force present. Even if I don't ask you for one, it's often good to draw one anyway. Yes?
Do we have to know the, oh wait, just kidding, you already said that, just kidding. I was gonna say the loss of motion, but you already said it.
Yes, you do have to, again, know the laws of motion and pick them out of a lineup. Examples of various forces we talked about include gravity, which again is a synonym for weight, tension, and how pulleys can redirect the tension within ropes, normal force, and how surfaces act perpendicularly out of themselves, and also both types of friction, static and kinetic. I've also added the word inclines there, which is in reference to the fact that on an incline, normal force and gravity are not equal and opposite, correct? You have to remember that for at least one test question. And the best way to summarize their relationship mathematically is to remember that the angle between normal force and gravity is the same as the slope of the angle of the incline. You may write this on your formula sheet.
Wait, can you repeat the second part?
Yes. This shows that on an incline, normal force and gravity are not equal and opposite. The normal force has to be perpendicular to the surface creating it. And if we draw these vectors tip to tail, the relationship between them is the angle between normal force and gravity is the same as the angle of the incline. So this theta is this theta. Gravity would be the hypotenuse, and the other leg besides normal force is whatever force is going on parallel to the incline. Since normal force and the slope themselves are perpendicular. Therefore, they are the two right-angled legs. And then, lastly, the stuff from chapter 5 this week, including work, the 3 forms of energy we talked about, and power. That is the comprehensive list of every unique type of thing that will be referenced on the test. If it's not written here, if it's not somehow indicated here, it won't be there. And the practice test summarizes all these concepts in ways similar to the test. If you can do the practice test, if you feel comfortable with how these concepts are used there, you'll be fine. You will also be fine if the practice test, well, if the practice test is hard, again, that it's designed to be harder than the real test. Because I'd rather you struggle on it than the test itself. How you guys feel? I know tests are scary, I know physics is scary, but I promise I would not write this test in a way that I wasn't confident you guys could do it. It is again built, weighted, and graded in a way that is meant to be for your benefit. I'm not trying to trick anyone or steal your grade from you. There's 2 tests, and also meaning if you just have a bad day next week, it's not going to tank your average, I promise. And I'm going to get everyone through it. You guys are going to do great, and I do have faith in you. Next week is again more studying. If you have encounter any questions or issues while working on the homework, the quizzes, or the practice test, please bring them to class. We'll talk about them together so everyone feels more confident about it. And have a great weekend. That's an official instruction from me.